So again, it's a quadratic equation. What we talked about yesterday was the importance of factoring because you change it from adding and subtracting to multiplying. But it only helps to factor if one side is equal to 0. So the first thing you would need to do is to make this equal to 0. Now this one factoring is a little bit more difficult because if you think about your first ones have to multiply to give you 6 sine squared theta, which means it's either 2 and 3 or 6 and 1. If you choose the wrong one, if you just go, oh, I'll pick 2 and 3, and it's wrong, then all your work after that, nothing will work. Some people do that. They just say, I'm going to try one and see if it works. And if it doesn't work, it must be the other one. And then try that one to see if it works. Okay? Now, for me personally on this one, if I have more than one option with my first numbers, because it's 6, which could be 2 and 3 or 6 and 1, I also check my last numbers, which is a 1. I only have one option for 1. It has to be a 1 and a 1. I do the signs last, plus or minus, so that has to be a 1 and a 1. And now, when I go to my first ones, I'm thinking already about my outside and my inside have to equal plus 1. Can you see that 6 and 1 is going to be bad? Because if I have a 6, my outside is 6, my inside is 1. 6 and 1 never make 1. But 2 and 3, now my outside is 2, my inside is 3, that can make 1. How could it make 1? If I had 3 minus 2, it would work. So I would need to make my inside positive 3, my outside minus 2, and a quick check, multiply this out. We would get 6 sine squared. Outside and inside give me 1 sine theta. And plus 1 times minus 1 is minus 1. So again, using the fact that you know how to multiply can help you figure out how to factor it. Now that you've factored it, split it here. If this one, now we've changed it to multiplying. So two things multiplied by 0. Either this one is 0 or this one is 0. If this one is 0, then sine of theta would equal negative a half. If this one is 0, then sine of theta is equal to 1/3. From here, we have to check, is a half on our pi plate? Yes. That's your pi over 6 family. But it's negative, so what quadrants are we looking for? Quadrant 3 and quadrant 4. But 1/3 is not on our pi plate. So this means you would have to do this side by calculator, doing the same thing that you would have done in the past for solving this. But now we're in radians instead of degrees. So the first thing you're going to make sure is you're going to turn on your calculator. That might take 5 minutes. And change it to radians. Oh, it's going pretty fast. Then you need to find your reference angle. You find your reference angle by doing sine inverse of 1/3. Reference angles are always positive. So I'll hit my mode button, make sure that I'm in radians. And now I go sine inverse of 1 divided by 3. My reference angle is, you know you've done too much math if you know this one, 0.34. Yeah, I've done too much math. 0.34 is our reference angle. Then, if sine is positive, according to our cast rule, does it make sense that it's in quadrant 1 or quadrant 2? So in quadrant 1, it will be 0.34. In quadrant 2, how would you figure it in quadrant 2? You would do all the way pi minus your reference angle and get 2.80. So these ones we could do from our unit circle. These ones, we needed a calculator. So this kind of question would always show up on a calculator part of your test. I'm going to add one more question. So do you have space on the back, or is there no space left anywhere? There's space? Okay. We're going to add one more question. We're going to add a question that, was everybody done? Were you done? Yeah? Okay. We're going to add one question where you have to use the quadratic formula. So, first of all, have I handed out your formula sheets? Yes. You have a formula sheet, but nobody. But I will, if I haven't handed out a formula sheet, I will do that right now. Yeah, because basically the only formula that you know on here is S equals theta R. Okay, 1, 2, 3, 4, 5. Let's see. Oops. It is a nice color. Did I send enough down this row? Lilac? I think so. Is it enough? Yes. Okay. So this might have even happened with the last example that we did. The last example we did could be factored, but you might have looked at the 6 sine squared theta plus sine theta minus 1 equals 0 and felt like, I don't know if I can factor this, or it's going to take me too long to factor it. Anytime you feel like you can't factor it, the quadratic formula is always an option. On your formula sheet, you have this. For ax squared plus bx plus c equals 0, x is equal to negative b plus or minus b squared minus 4ac over 2a. That is your quadratic formula, and it's on your formula sheet. It only works if you have something squared plus something x plus c equals 0, which we have. And notice that whatever is squared goes there. That's important. In grade 11, it was always x squared. Okay, now we have tan squared. It's tan that's getting squared, so instead of x equals, this question, when we go to solve it, we'll start off with tan theta equals. The b value is 2, so we'd have negative 2 plus or minus 2 squared, which is 4, minus 4, a is 3, c is negative 7 over 2 times a. This would be the setup. We just plug the numbers in that we have. The important thing is that it's now tan theta equals instead of x equals, because in the formula sheet it's for ax squared, but we don't have x squared, we have tan squared. So then we would write tan equals instead of x equals. Plug in the numbers. This would still be your a value, your b value, your c value. And we can simplify this, which would give me tan of theta equals -2 plus or minus. All right, what do we got? 84 plus 4, 88 over 6. How do I get -7? How did you get -10? Were you adding instead of, I don't know. Okay. Now, how do we deal with this? First of all, just to check, is that on your unit circle? No, absolutely not. I hope not. Okay? What the plus or minus means is you actually have two separate equations. And at this moment, I'm going to write them separately. One of the equations is with the plus sign. And one of the equations is with the minus sign. And each of these happens to be a number. I mean, we can type it into our calculator. I'll use the fraction button, so I have -2 plus the square root of 88 divided by 6. So this one happens to be 1.23. Dot, dot, dot. And this one we could figure out as well. If I want to do that quickly, just retype what I had. Oops. And change that to a minus sign instead of a plus sign. And -1.89 dot, dot, dot. Having calculator troubles over there? See, I use the fraction button. If you have a fraction button, that's very helpful. If you don't have a fraction button and you got something different, it's probably because you didn't put an extra set of brackets around the top, because you have more than one thing that you're dividing by 6. So to show that on your calculator, if you put that top part in brackets, it's going to divide it all by 6. Now that you've used your quadratic formula and got to this point, now it's back to a regular grade 10, grade 11 question. We're just dealing in radians. How do you solve this once around the circle? You're going to need your reference angle and your cast rule. And then you can find out what quadrants it's in. So for the first one, okay, I'll go back up. I'll retype this in. That was our first one, 1.23. How do I find my reference angle? I go tan inverse of that number, push enter. My reference angle is 0.888. If I want to find theta, according to my cast rule, here tan is positive, so it's either in quadrant 1 or quadrant 3. In quadrant 1, then, it would be exactly the same as my reference angle, 0.888. In quadrant 3, I would go pi, halfway around, plus my reference angle. So I can write that just above here. Type that into my calculator, pi plus the answer that I just had, which was my reference angle, and I get 4.03. That solves the first set of equations. To solve my second set of equations, I'm going to need to find my reference angle for this one. And when finding a reference angle, it's important that you always use the positive number. So I'm going to put a positive in green there. Reference angles are based on actual triangles with positive side lengths. So reference angles always use positive values. And so if I go to my calculator and I take this answer that I had before, I multiply it by a -1 to make it positive. Now it's a positive number. I can go tan inverse of that answer and get my reference angle is 1.0856. Then according to my cast rule, since tan is negative, I'm going to look in quadrants 2 and quadrants 4. If you have a graphing calculator, you might want to use the store button. The store button's right above the on button. So I hit store. I like to just use the letter X beside alpha. It temporarily stores that reference angle of 1.085 as X. What that allows me to do is when I want to find my actual angle, one of them is in quadrant 2. In quadrant 2, it would be pi minus my reference angle. And the other one is in quadrant 4. In quadrant 4, it would be all the way around, which is 2 pi minus my reference angle. So the reason storing it is nice is now I can just go pi minus, and I stored it as x. So I can just go pi minus x and push enter, 2.056. And the second one, I can just go 2 pi minus x, because I had stored it, 5.198. So this is one with the quadratic formula. If we look at the whole question at once, what did we have to do? We had to solve this. We could not factor it, so we used the quadratic formula, which, because of the plus or minus, gave us two possibilities. The possibilities were fractions, and it was hard as a fraction to tell which one's positive, which one's negative. So I typed them into my calculator, found out the one on the left was 1.23, the one on the right was negative 1.89. And now it's just like any other question you've done with a calculator in the past with trigonometry. Any trig question from once around the circle, you have to find your reference angle, then use your cast rule to find out what quadrants it's in. Once you have your reference angle, quadrant 1 is exactly the same as your reference angle. Quadrant 3 is pi, because halfway around plus your reference angle will be your value. Here we had quadrant 2 and quadrant 4, so you would do halfway around pi minus your reference angle for quadrant 2, and all the way around minus your reference angle for quadrant 4. So you will get some questions non-calculator, right? That you can factor without a calculator, use your pi plate without a calculator, and get all the values. Some questions where it's a mix of calculator and non-calculator, like the last one that was actually typed in your notes. And then there are some completely calculator questions, like this one, where you have to use your calculator to find all the answers. All right, so that's the end of the extra note booklet.